Hello, this is a pre-lab video for experiment number 1, that is the intro to lab techniques. So this lab is kind of a starter for us because in Chem 106 lab, we are going to be doing some techniques that are different from the ones that you did in General Chemistry 1, and you need to be aware of those techniques and be able to use them appropriately. So let's get into the experiment itself. And so what we're going to see is that this lab is relatively straightforward, and we're really just trying to do just a couple of little things here. We want to learn some separation techniques. So when it comes to if I have a solid and a solution, or a solid and a liquid, how do I get them apart from each other? And how do I do it, especially in ways that are faster than things like filtration, which can take forever and gets a lot of product loss. And if you remember from Gen Chem 1, anytime we did any kind of filtration, whether it was vacuum or gravity, it took a long time. It generally yielded poor results. So how do we combat that? How can we do that faster? And so we're going to talk about centrifuging as one way to do that and do it much more efficiently. What kind of techniques can we use to dissolve solids? We'll talk in this particular experiment about complexing, which is something that you haven't seen before, at least not many of you. We will also talk about just simple acid and base reactions and kind of using the acidic and basic properties of certain kinds of compounds to dissolve them. And then we'll get into some net ionic equations. You're going to start off with real strong, how do you do net ionic equations, going back to those wonderful days of Chem 105, where you had to do all of those net ionic equations and do them properly. So when it comes to this experiment in particular, there are some techniques that we are getting into. And we'll get a real good sense of using them. We're going to do 3 qualitative analysis labs over the course of this semester, where we separate different metal ions from each other based upon varying reactivities. And this is going to be how we do it. So you see in the discussion here, we give you a little bit here about how to form a precipitate, what it looks like, how to properly heat a test tube, what the difference is between centrifuging and decanting. So in a centrifuge, what we are going to do is we're going to use the power of gravity at high speeds to spin a test tube round and round and around and around inside of this instrument. And what that's going to do, the gravity of that spinning is going to cause the solid to push down toward the bottom because it's more dense, and the liquid's going to be left on the top. And that separation will allow us to do something called decanting. Decanting is where we pour the liquid off of the solid. And so in cases of qualitative analysis, where it's usually good, where we actually need both the liquid and the solid, this allows us to separate those two and have both of them on hand for later testing. This is different from washing. When we wash a precipitate, we are usually going to rinse that precipitate in some kind of solvent, usually water, but sometimes water with other kinds of agents in it to help remove impurities. And in those cases, we don't care about the liquid. So after we mix up the wash liquid and the precipitate, we're going to centrifuge it again, and we'll decant to get the liquid off of the solid. But unlike when we decanted in the previous, we're not going to save it. The wash water always gets discarded because it's of no use to us. It just has impurities in it. So the techniques that we're going to get into here are these: how to make a precipitate, how to purify a precipitate, how to separate a liquid that we're interested in from a solid that we're interested in, How to properly evaporate a solution, because sometimes we'll make a whole bunch of solution and we actually need to concentrate it before we do the next step in the analysis. How do we do that? That's where an evaporating dish comes in, and that's where the name evaporating dish comes from. Playing with solution pHs, using acids and bases, using litmus paper to help us determine if we've gone acidic enough or basic enough. And then some just general procedures here. So I encourage you to go through this, read this kind of up front before tomorrow's lab. It's going to make a world of sense when you actually get to it tomorrow and look at it. From a safety standpoint, there are going to be some physical hazards involving glassware. There's also hazards involved with using centrifuges. Now, tomorrow I'll give you a more detailed look at how to properly use a centrifuge, especially for those of you that have never used one. But you need to be aware. Chemical hazards mainly fall around what the reagents are. Most of the reagents here, with the exception of the 6 molar hydrochloric and the 16 molar nitric acids, are really not too bad. But you don't want to ingest them, certainly. And some of them, like the ammonium sulfide and like the ammonia here, aren't going to smell very good, and can be corrosive to you. So read through the hazards piece here individually. Now, this lab does not have a pre-lab. It doesn't. But what it does have is this, just kind of giving you an idea of what a pre-lab might look like. So usually in the pre-lab, there are questions like, what is the purpose? Why do we do some of the things that we do? What kinds of reactions are taking place when we do these? What are the purposes of this step or that step? So in the experiment itself, you'll see that we're actually only going to be doing 5 experiments. And part of the reason for this is because we really want to focus on the technique and getting the technique right. And so we're not going to inundate you with doing dozens of procedures. We're going to give you 5 just to kind of work on practicing and getting it right. And also because there are going to be other things that we do tomorrow, like checking into lab drawers and reviewing safety information and getting everybody into lab archives and all of that kind of stuff that goes with the first day of classes. But you can see that the procedures here are relatively straightforward. What you're going to do in each case is this. You're going to start with solutions. You are going to add one solution to another, and it's going to form a precipitate. And then you are going to do a series of things to that precipitate to try to get it to dissolve again. And that's what you're going to do in all 5 of these cases. Iron 3 chloride and ammonia. We're going to add ammonia to the iron 3 chloride until we form a precipitate. Then we're going to continue to add ammonia, see if that causes the iron compound to dissolve. If it does, that's something called a complex, which we'll talk about a little bit more tomorrow. If it doesn't, then we move on to the next step. We try to do an acid-base reaction, because the product here that we're going to form is the iron 3 hydroxide, FeOH3. Now, you might be looking at this and saying, okay, well, where's the hydroxide coming from? We're adding ammonia. Well, what you have to remember is that ammonia in water is NH4OH. And so as a weak base, this hydroxide is able to grab onto the iron here and form the precipitate iron 3 hydroxide. And what we're testing here is, does this turn into the complex ion where the ammonia basically becomes so concentrated that it undergoes a different kind of acid-base reaction, a Lewis acid-base reaction with the iron to form a complex, or does it instead react with the hydrogen ion? And we go kind of back to where we were before. So that's the question you're going to be asking in each of these is, do we form a precipitate? The precipitate in all of these cases is hydroxide, with the exception of the last one. The last one, it's sulfide, copper 2 sulfide. But the question we ask is, do I form a complex, or do I do a neutralization to get the precipitate to dissolve? And so that's what the basic idea of this experiment is. So again, not terribly difficult, but what we do want you to do, we want you to focus on the technique: centrifuging, washing, decanting, purifying, getting things to dissolve, noting your observations. So you'll see observations table here. This is the reaction that took place. What did the precipitate look like? Did it dissolve in excess reagent? Did it dissolve, or did it dissolve in acid? Here's the reaction equation in net ionic form for the precipitation. And then based upon your results, did it react in C or did it react in D? What is the reaction equation for the dissolving? So this is what you'll be doing for all 5 of these. Relatively simple, relatively straightforward, but good kind of, let's get our feet wet and get back to the swing of things in the semester. So that's all for this particular experiment. Now, I'll be releasing a third video later this week with some information about how to handle the pre-lab activity for the lab that we're going to be doing on Thursday, the calorimetry lab. So stay tuned for that. But until then, take care, and I will see you in lab.